Okay, so we have question 7. It says in the circuit diagram below, the battery has an EMF of 6 volts and negligible internal resistance. Now 7.1 says calculate the effective resistance in the circuit. In order to calculate the effective resistance, let's first find out the connection of the circuit. Let's understand the connection here. Right, so we have the 4 ohm resistor and the 2 ohm resistor. They are connected in series, but a combination of these resistors will be parallel to this 3 ohm resistor. So in order to calculate the effective resistance here, we'd first need to add this. So this is 4 ohm plus 2 ohm, and then that will give us 6 ohm, and then make it parallel to this 3 ohm. So this is how we are going to approach the question. Let's first find the ones that are connected in series. So this is the 4 ohm plus the 2 ohm, which will give us 6 ohms. But then remember, a combination of those resistors that are in series is in parallel with the 3 ohm resistor. So we have 1 over Rp is equals to 1 over R1 plus 1 over R2. So what is our R1? Now it's going to be that 6 and then 1 over 3. Now adding this, our 1 over Rp will give us 1 over 2. So if we do the inverse for this, the Rp will now be equals to 2 ohm. But then remember that now will be the effective resistance. So the effective resistance is 2 ohm. So that's the total resistance of this circuit. 7.1.2 says calculate the reading on ammeter A1. So where is A1? We can see that A1 here is connected in series to the battery. So that means A1 here is reading the total current, right? So if we have A1 here reading the total current, that means we can find A1 here by using the total voltage, which is the EMF here, 6 volts. And remember, in the previous question 7.1.1, we calculated the effective resistance, which is the total resistance, and it gave us 2 ohms. So using the 2 ohms, the total resistance or effective resistance, and the 6 volts EMF, we can get the total current. So using the formula, R is equals to V over I, right? So the effective resistance, remember, we had 2 ohms, and then what is the voltage? The EMF is 6, and then over I. So if we cross multiply here, we have I is equals to 6 over 2, then our current is definitely 3 amperes. Now 7.1.3 says calculate the reading on ammeter A2. Now where is A2? We can see that A2 here is connected in series to these 2 resistors, the 4 ohm and the 2 ohm, right? But then remember, we have calculated that this they give us a resistance. As a combination, they will give us a resistance of 6 ohms. Now we can use this total resistance of the series and the current and the voltage that flows in here in order to calculate the current that flows in A2. So for A2, we have R is equals to V over I. Then the resistance is 6. And then the voltage is 6. Why is the voltage 6? Remember, we say this, all this, a combination of this is connected in parallel to this, right? And we know with parallel resistors, the voltage is the same throughout, right? So if here, reading here, this will be our 6 volts, and also a combination of this will have 6 volts, right? So we say if they are parallel, the voltage is the same throughout. Now we have this, if we cross multiply here, we have I is equals to 6 over 6, and then our current is equals to 1 ampere. So that will be the reading on A2. 7.1.4 says calculate the power dissipated by the 4 ohm resistor. Calculate the power dissipated by the 4 ohm resistor. Now we have already found that A2 reads a current of 1 amperes, right? But then with this, the 4 ohm resistor and the 2 ohm resistors are connected in series. That means this 1 ampere is reading the current of the 4 ohm and also reading the current of the 2 ohm. Right, which is, since we know that if our resistors are connected in series, the current will be the same throughout. That means the 4 ohm resistor reads 1 ampere and also the 2 ohm resistor reads 1 amperes, right? So now we are required to calculate the power dissipated by the 4 ohm resistor. So we know that power has this formulas, which is PV times I, and then P is equals to I squared times R, and also P is equals to V squared over R. Now, having the information that we have here, we can see that we have the current of the 4 ohm resistor and we also have the resistance. So that means we can pick out this formula and use it to calculate the power. So approaching this one, we have P is equals to I squared times R, right? Then what is our current? It's 1. And then what is our resistance? It's 4. So 1 squared times 4, that will give us 4 watts, right? And that's our power. Now 7.2 says, what is the reading on voltmeter V? No calculation required. Now this one we've already spoke about it. We said this parallel, right? So that means if we have 6 volts here and then we say all this is parallel to the 3 ohm resistor, that means we'll have 6 volts for the two for these 2 resistors. And then also here it's supposed to be 6 volts because we say if resistors are connected in parallel, then the voltage is the same throughout. So that's why it says no calculation and it's only 1 mark. So we are only required to say it's 6 volts based on the knowledge that we know that if resistors are connected in parallel, then the voltage is the same throughout. So that's 6 volts. Then 7.3 says a kettle is rated 1500 watts. Then calculate how much a learner will pay for electricity for using the kettle for 4 hours. So we are given the time there 4 hours, and then it says Eskom charges 1 kilowatt per hour electricity at 2.05, right? So now we are required to calculate the cost of electricity. Now, when it comes to calculating the cost, we know that our power should always be given in kilowatts. As we can see here, that Eskom charges in 1 kilowatt. But then here we are given that the kettle is rated in watts and not in kilowatts. So in order to convert watts to kilowatts, we know that we'll have to divide by 1,000. So that's the first step in dealing with this one. We have the 1005 and then we just divide it by 1,000. Then we know that's 1.5 kilowatts, right? Now, in order to calculate the cost, now we have to first calculate the energy. So energy is equals to power and multiply by change in time. Now, what is the power? It is that 1.5. And then remember, we are told that the learner uses this kettle for 4 hours. So 1.5 times 4, and then that will give us that should give us 6 kilowatts per hour, or 6 kilowatts an hour. Then remember, we are told that for 1 kilowatt hour, Eskom charges 2.05. So in order to find the cost for 6 kilowatt per hour, we know that we'll have to cross multiply this here, right? So in order to calculate the cost, we'll now say this is 6 multiplied by 2.05, and the cost should give us 12 rand point 30 cents.